This is the Big Bang, a cosmic explosion that gave birth to space, time, matter, and everything else that exists. From that same event, our solar system came into being, and from this very solar system, we launched a spacecraft called Voyager, which today is the furthest human-made object ever sent out into space. But even Voyager has only made it to the boundary of the solar system. In other words, we humans still have not truly stepped beyond the walls of our own cosmic home. But hold on for a second. The solar system has a boundary. The Milky Way has a boundary. So does the entire universe also have some kind of boundary. Some wall beyond which there is nothing at all. No space, no time, no reality. Now look, there really is something like a wall in the universe, but it is not wrapped around the whole universe. It surrounds only us. It stretches across roughly 90 billion light-years around Earth. And the terrifying part is that this wall is constantly moving closer to us. At the exact moment you are watching this video, in that same second, 60,000 stars have already vanished forever from the observable universe. We will never be able to see them again, because there is an invisible wall surrounding us in the universe, and whatever crosses beyond it is lost forever. No rocket, no spaceship, no signal can make it past that wall. But the most chilling part is this. Every second, that wall moves closer, and every second it consumes another piece of our observable universe. So could this actually be the edge of the universe? For example, the observable universe contains around 2 trillion galaxies. That is a 2 followed by 12 zeros. So many galaxies that even if you counted one every second, it would still take you 63,000 years to finish. But out of those 2 trillion galaxies, 94% have already passed beyond this invisible wall. That means nearly 94% of everything you see in the sky is already gone forever as far as you are concerned. But what exactly is this invisible wall of the universe? Why is it steadily moving toward us? And why do scientists say that one day this invisible boundary will swallow the entire universe and leave behind a dead dark cosmos? December 18th, 1995. On that day, Hubble Space Telescope director Robert Williams made a decision so unusual that people inside NASA started calling him crazy. Williams decided that he would point the Hubble Space Telescope toward the darkest, emptiest patch of the sky, toward a region where no star was visible, no galaxy was visible, nothing at all could be seen, just a completely black patch, and he planned to keep Hubble locked onto that darkness continuously for 10 days, without moving it. NASA scientists said this was a complete waste of telescope time. Every minute of Hubble was extremely precious, and here he was spending it on empty black sky. Some people even said this decision would destroy Williams' career. But Williams ignored them all, and Hubble continued staring into that darkness for 10 straight days. A total of 342 images were taken, and when all of them were combined into one final picture, the entire world was left speechless. Because in that empty darkness, where nothing at all seemed to exist, more than 3,000 galaxies were hidden. Every tiny blurry dot was an entire galaxy containing billions and trillions of stars. Some of those galaxies were so distant that their light had begun traveling 12 billion years ago. That means we were looking at galaxies that formed shortly after the birth of the universe itself. That image came to be known as the Hubble Deep Field, one of the most important images in human history, because for the first time it revealed that the universe is billions of times larger than we had ever imagined. But today, when scientists look back at that same image, they do not feel joy. They feel sorrow, because most of those 3,000 galaxies have now moved so far away that their light will never reach us again. That means we saw them, and then we lost them forever. And the reason is this same invisible boundary surrounding Earth in the universe. But what exactly is that boundary? First, understand one basic thing. How big is the universe? You have probably heard that the universe is about 13.8 billion years old. So naturally, you might think we should be able to see 13.8 billion light years away, right? But that is not actually true, because the universe is like a balloon that keeps expanding all the time. Just as 2 dots drawn on a balloon move farther apart as the balloon inflates, galaxies too move farther away from one another. That means the galaxy that sent light toward us 13 billion years ago is now much farther away than it was then. Why? Because the space in between has stretched. That is why today we can see not merely 13.8 billion light years out, but as far as 46 billion light years, which means the observable universe has a total size of about 93 billion light years. That sounds unbelievably huge, doesn't it? But now comes the real point, because seeing something and reaching it are two very different things. You just heard that we can see as far as 46 billion light-years away, but can we actually travel there? The answer is absolutely not, because as I told you, those galaxies are also moving away from us. And how fast are they moving? So fast that it sounds impossible, faster than light. Now you might say Einstein proved that nothing can move faster than light, and that is correct. But here is the trick. The galaxies are not moving through space. Space itself is expanding, and there is no speed limit on the expansion of space. So the galaxies are staying in place relative to their own local regions, but the distance between us and them is growing so quickly that their light can never reach us. Now listen to an even more frightening number. There are around 2 trillion galaxies in the observable universe. So many that if you counted one galaxy every second, it would still take you 63,000 years. But out of those 2 trillion galaxies, only 6% are galaxies we could ever possibly contact in the future. The other 94% have already moved so far away that no rocket, no signal, not even a beam of light will ever be able to reach them. But why are these galaxies racing away from us? Why is the space between them expanding? To understand that, let us go back to the year 1998. That year, scientists made a major discovery. They observed a special kind of stellar explosion in distant galaxies known as Type 1r supernovae. Now, what makes these supernovae special? They always explode with a fixed brightness. So if you know a bulb is 100 watts and it appears dim to you, you immediately know it is far away. In the same way, scientists measured the brightness of these supernovae, but when they did, they found something shocking. The supernovae were dimmer than expected, which meant they were farther away than expected. And there was only one possible conclusion. The expansion of the universe was not slowing down, it was accelerating. This discovery was so significant that it earned the Nobel Prize in 2011. But the scariest part is this. Why is the expansion accelerating? No one knows, even today. Scientists gave this mystery a name, dark energy. But giving something a name is not the same as understanding it. What is dark energy? How does it work? Where did it come from? Nobody knows. All we know is that about 68% of the total energy content of the universe is this dark energy. And this same dark energy is rapidly stretching space itself, causing galaxies to rush away from us. Because of this dark energy, an invisible boundary has formed in the universe. Scientists call it the cosmological event horizon. Think of it like this. Imagine you are standing on an island. All around you is the sea. Now imagine the sea itself is pulling away from you. Earlier, you could have swum to another island. But now the water is moving away so quickly that no matter how fast you swim, you can never reach that other island. And with every passing second, the gap becomes larger. That is exactly what is happening in the universe. That invisible line surrounds us. Anything beyond it is receding so fast that even light from there can never reach us. It is similar to a black hole, except a black hole is tiny compared to this. This horizon is around us in every direction. So now the question is, if 94% of the universe has already crossed beyond that invisible boundary and left our reach, what exists in the remaining 6%? Well, our home is something called the local group. It is like a galactic neighborhood. It includes the Milky Way, the galaxy we live in. It includes the Andromeda galaxy, which is the closest major galaxy to us. It includes the Triangulum galaxy, along with more than 50 smaller galaxies. Altogether, this group stretches across an area of roughly 10 million light-years. One important thing to understand here is that the galaxies inside this group are gravitationally bound to one another. That means the space between them is not expanding. Just as Earth is not drifting away from the Sun because gravity holds it in place, the galaxies inside the local group are also holding on to one another through gravity. But everything outside the local group is moving away from us. Now, the nearest galaxy group just outside the local group is the Maffei group. How far away is it? About 10 million light-years. And 10 million light-years means that even if you could travel at the speed of light, which is the fastest speed possible in the universe, it would still take you 10 million years to get there. And of course, traveling at the speed of light is currently impossible. If some civilization could travel at 10% of light speed, the journey would still take 100 million years. At 1% of light speed, it would take 1 billion years. Now think about that for a moment. How could any species survive inside a spaceship for 100 million years? And over time, even these nearby groups will continue moving farther away from us. One day, they too will cross that invisible horizon, and when that happens, we will truly be alone. Now forget the outside universe for a moment, and let us focus on what is happening inside the local group. Everything is fine here, right? Not exactly. Even here, something big is happening. The Milky Way and Andromeda are moving toward one another. Back in 2012, NASA said that in about 4 to 5 billion years, the two galaxies would collide and merge. But in 2025, a new study published in Nature Astronomy, using updated Gaia satellite data, suggested that this collision may not be so certain after all. Some models showed a 50% chance that no collision would occur even within 10 billion years. But then in another study in 2026, the probability rose again to nearly 90%. So even now, no one can say with complete certainty whether it will happen or not. But if it does happen, the two galaxies will merge into one giant galaxy that scientists have named Milkomeda. But now comes the part that is truly thought-provoking. The birth of new stars in the universe is slowing down. Very slowly, but steadily. There was a time in cosmic history, around 10 billion years ago, when star formation was at its peak. Back then, the universe was producing stars about 10 times faster than it does today. In the present-day Milky Way, only about 3 new stars are formed each year. In an entire galaxy, just 3, and that number will continue to fall. Most of the stars that were ever going to be born have already been born, which means we are living in an era of the universe where the light is gradually fading. Now let us talk about the future, the very distant future. As time moves on, every galaxy outside the local group will drift farther and farther away from us. First it will become slightly dimmer, then even dimmer, then so faint that even the most powerful telescope on Earth will no longer be able to detect it. Physicist Abraham Loeb has shown that one by one, all distant galaxies will vanish from our view. But galaxies are not the only thing that will disappear. Something else will vanish too, the cosmic microwave background. This is the ancient radiation that was formed about 380,000 years after the Big Bang. Think of it this way, after the Big Bang, when the universe cooled down enough, a kind of faint glow was released. That glow is still present throughout the universe today. Right now, its temperature is about 2.725 Kelvin, but as the universe continues to expand, that glow will become weaker and weaker. Eventually, it will become so faint that observers living inside a galaxy will not be able to detect it at all. Now think about what that really means. If billions of years from now some intelligent species arises in Milkomeda, and they look up at the sky, what will they see? Only their own galaxy. Beyond it, only black emptiness. No other galaxies will be visible. They will not detect the CMB either. There will be no sign of the Big Bang. They may conclude that the entire universe is nothing more than a single isolated galaxy suspended in darkness. They will never know that once there were 2 trillion galaxies here. They will never know that the universe was once overflowing with light. They will never know that a species like ours once existed and was able to witness all of it. Scientists Lawrence Krauss and Robert Scherer called this future the end of cosmology. A future in which cosmology itself becomes impossible because all the evidence will have disappeared. And star formation will not continue forever either. According to the work of scientists Fred Adams and Gregory Laughlin, stars may continue forming for roughly 10 to the power of 14 years. After that, no new stars will form. The stars that already exist will slowly exhaust their fuel and fade away. First the massive stars will die, then the medium-sized stars, and in the very end, only red dwarf stars will remain, burning not for billions, but for trillions of years. But even they too will eventually go dark. And after that, what will be left? White dwarfs, neutron stars, black holes, and darkness. Nothing but a cold, black, silent universe where nothing remains. Neither humans nor any other life form would survive, because there would be no source of energy left to support life or growth. Of course, there are still many theories beyond this. Some suggest that if humanity continues to advance for that long without destroying its own civilization, then by that point we may have learned to travel through the multiverse. So it is possible that by the time our universe is reaching its end, we may already have migrated into a completely new one. So now tell me, what do you think? Will humanity survive until the very end of the universe? The comment section is open, so make sure to share your thoughts. If you enjoyed this video and learned something new, then give it a like and definitely share it with your friends as well. And if you liked this video, then I would strongly recommend that you check out the next one, where we explored a concept of time paradox that will seriously blow your mind. Time travel, in itself, is such an idea that creates countless contradictions. It gives rise to many paradoxes, and in that video we talked about one of those paradoxes that you are going to find incredibly interesting, so do go watch it. I will see you in the next episode. Until then, goodbye.